Sometimes you may want a program to exit out of a loop it is currently running through. Fortunately, there's something called a break statement that can help you accomplish this task. When a break statement is executed, the program exits the loop and the program proceeds normally afterward. So in this example, initially I is 0, 0 is less than 5, it prints 0, this if statement is false, so then I print 0 again. Then I becomes 1, then it prints 1, and then 1 again. Then I becomes 2, then 2 is less than 5, so it prints 2. Then this time I is 2, so then it executes the break statement. Then what happens is that the program stops executing this for loop, even though the condition is still true. Then it continues proceeding normally, and in this case printing the words outside the loop. Here's another example of using break statements, this time with a while loop instead of a for loop. So in this example, notice that the condition is true, which means that the while loop will always execute until we hit a break statement. So we're relying on a break statement to exit out of this loop. In this example, initially u1 is set to 20. Then we go on with the while loop. We print 20. u1 becomes 25. 25 is not less than 10, so we go on. u1 becomes 8. Note that this is integer division. Then we go on, since true is the condition. Then we print 8. Then u1 becomes 13. 13 is not less than 10, so then u1 becomes 4. Then we print 4. Then u1 becomes 9. Then afterward, now u1 is less than 10, so we hit the break statement, which means that we exit out of this while loop and we proceed with the rest of the program, which in this case is a single print statement that prints u1, which is 9. Another statement commonly used in loops is the continue statement. When the continue statement is executed, it skips the current iteration of the loop and goes on to the next one. And this can be illustrated with an example. Initially, I is 0, 0 is less than 5, so it prints 0. Then 0 is not equal to 2, skips the if, and then prints 0. I becomes 1, 1 is less than 5, so prints 1. 1 is not equal to 2, so it prints 1. Then I becomes 2. Then it prints 2. Then I is equal to 2, so it hits the continue statement. And what the continue statement does is it skips the rest of the for loop iteration, and it goes directly from the continue statement to the I++. And every single time a continue statement is used in a for loop, that happens. It goes to the statement after this second semicolon, so the third area in the for loop. Then afterward, I becomes 3. 3 is less than 5, so then it prints 3, and 3 is not equal to 2, so it prints 3. Then I becomes 4, prints 4, and prints 4 again. I becomes 5, then this time the condition is met, and then we exit out of the for loop and we proceed normally, printing outside the loop. And notice that continue statements differ from break statements in that break statements go from them to the outside of the loop, while continue statements go from there to the third statement in the for loop, parentheses. And in an example involving a while loop, you'll see that when a continue statement is executed in a while loop, since there is no third statement in the parentheses, it just directly goes to the checking phase and goes on to the next iteration. So in this example, initially u2 is 23. Then 23 is greater than 0, so I print 23. Then u2 becomes 18. Then 18 is greater than 4, so I continue. And continue means I skip these two and go to the checking phase. 18 is greater than 0, so then I print 18. Then u2 becomes 13. Then 13 is greater than 4, so I continue, which means I check 13 is greater than 0, prints 13. Then U2 becomes 8. 8 is still greater than 4, so then I continue, which means that now 8 is greater than 0, so I print 8. Then U2 becomes 3. 3 is no longer greater than 4, so I don't continue. Then U2 becomes 6, and I print 6. Then 6 is greater than 0, so then I print 6. Then U2 becomes 1. 1 is not greater than 4, so I don't continue. Then U2 becomes 2, and I print 2. Then 2 is greater than 0, so I print 2. Then U2 becomes negative 3. Then negative 3 is not greater than 4, so then U2 becomes negative 6. And then I print negative 6. Then negative 6 is no longer greater than 0, so then we're done. Here's an exercise. Determine the output of the following code. So initially, U3 is 0. Then, since the condition is true, I print 0. 0 is less than 10, so then U3 becomes 5. Then I continue, which means that I go back to the condition, which is true, so then I print 5. Then 5 is less than 10, so then U3 becomes 10. Then I continue, which means I go back to the condition. Then I print 10. 10 is not less than 10, so I don't execute this block. 10 is less than 50 though, so then U3 becomes 30. And then I continue, which means that I go back to the condition, which is true, so I print 30. 30 is not less than 10, but it is less than 50. So then U3 becomes 50. Then I continue, which goes back to the condition, which is true. So then I print 50. 50 is not less than 10, and it's not less than 50, so we go on to execute the break statement, which quits this while loop, and we're done. Just like if statements, loops can also be nested. In this example, we have two for loops nested within each other. To determine how this type of structure works, let's go over the output of this. So initially, I equals 0. 0 is less than 3, so then I go and execute this block. Then, when I execute this block, j equals 0. Then j is less than 3, so then I print 0, 0. Then afterward, I go to j++ because I'm still inside this for loop, and then j becomes 1. Then 1 is still less than 3, so then I print 0, 1. Then next, j becomes 2. 2 is less than 3, so then I print 0, 2. Then afterward, j becomes 3. 3 is no longer less than 3, so then I'm done with this for loop. Then, since I'm done with this for loop and there's nothing else inside the body of the outer for loop, I go to I++, so I becomes 1. Then 1 is still less than 3, so I execute this block one more time. So then, j starts out as 0, then 0 is less than 3, so then I print 1, 0. Then I go to j++, so now j is 1. 1 is less than 3, so I print 1, 1. Then I go to j++ again, j becomes 2, and I print 1, 2. Then I go to j++ again, j is 3. 3 is no longer less than 3, so I'm out of this for loop. And then I go to I++ after we're out of this for loop, because there's nothing else in this body. Then I becomes 2, and we execute this for loop again. So then j becomes 0. And 0 is less than 3, so we print 2, 0. Then j becomes 1. 1 is less than 3, so we print 2, 1. J becomes 2. 2 is less than 3, so we print 2, 2. J becomes 3. And then 3 is not less than 3, so we're done with this for loop. And since we're done with this for loop, we're done with j, and we go to I++ because there's nothing else in here. So then I becomes 3. 3 is not less than 3, so then we're done with this for loop, and then we're done with the entire program. So that's the output. Here's an exercise. Determine the output of the following. So initially, I is set to 0. 0 is less than 3. So then I start executing this block of code. So j becomes 0. J is less than 4. So then I print I plus j, which is 0. And notice this is print, not println. Then j++, which means that j is now 1. 1 is less than 4. So then I print 0 plus 1, which is 1. Then j becomes 2. 2 is less than 4, so then I print 0 plus 2, which is 2. J becomes 3. 3 is less than 4, so it prints 3. J becomes 4. 4 is not less than 4, so I'm done with this for loop. Then I proceed normally, which is system.out.println. Then I'm done with this one iteration of this for loop. So then I execute I++, which means that I is now 1. And 1 is less than 3, so now I execute this for loop again because it's the first thing in the body of the outer for loop. Then j becomes 0. J is less than 4, so then I print 1 plus 0, which is 1. Then j becomes 1. 1 is less than 4, so I print 2. J becomes 2. I print 3. J becomes 3. I print 4. J becomes 4. Then 4 is no longer less than 4, so I'm done with that for loop. Done with j. Then I do system.out.println. Then I'm done with this iteration, so then I go to I++. I becomes 2. 2 is less than 3. So then now I execute this for loop again. J is 0. 0 is less than 4. So then I print 2 plus 0, which is 2. J becomes 1. 1 is less than 4. Prints 3. J becomes 2. Prints 4. J becomes 3. And then prints 5. And then j becomes 4. And then 4 is no longer less than 4, so I'm done with this for loop. Done with j. Do system.out.println. Then I go to I++. I is 3. Then afterward, 3 is no longer less than 3, so then I'm done with this for loop. And I'm done with the entire program. Here are a few exercises. So the first one, u is 3. Then condition is true, I print 3. 3 is not 1, 3% 2 is not 0, so then u becomes 10. Then prints 10 in the next iteration. Then u is not 1, but u% 2 is equal to 0. So then u becomes 5, and then I continue, which means I go to the condition, which is true, which means I print 5. Then the if statements are false, so then u becomes 16. Then I print 16. U becomes 8 because 16% 2 is 0. Then in the next iteration I print 8. U becomes 4. I print 4. U becomes 2. I print 2. U becomes 1. I print 1, then this time u is 1, so I break, which means I'm done with the for loop and done with this exercise. Next exercise, first I is 0, so then basically j is 0, and then I print 0, 0, then j plus plus, so now j is 1, 1 is less than 3, I print 0, 1, then j becomes 2, print 0, 2, j becomes 3, 3 is not less than 3, so then we're done with the inner for loop. I becomes 1, then j becomes 1 because j is initially set to I. 1 is less than 3, so then prints 1, 1, then j becomes 2, prints 1, 2, j becomes 3, then the inner loop stops because 3 is not less than 3, then I becomes 2 after I plus plus, then j becomes 2, prints 2, 2, then j becomes 3, then we're done with the inner loop, I becomes 3, we're done with the outer loop, and we're done with the exercise. The next exercise, first I is 0, then j is 0, prints dot, notice it's system.out.print, then j becomes 1, prints dot, j becomes 2, prints dot, j becomes 3, prints dot, then j becomes 4, and stops the inner loop. Then system.out.println, then I becomes 1, j is 0, prints dot, then j becomes 1, prints dot, j is 2, prints dot, j is 3, prints dot, then j is 4, stops, then system.out.println, then I becomes 2, j is 0, prints dot, and so on. And the result should be like this 4x4 grid of dots if you did the exercise right. Next exercise. So first, I is 0. Then j is 0, prints dot, then j becomes 1, but then 1 is not less than or equal to 0, so then I stop after the system.out.println. I is 1, then j is 0, prints dot, j is 1, prints dot, then j is 2, 2 is no longer less than or equal to 1, so then I stop the inner for loop, do system.out.println, then I becomes 2, then j becomes 0, then print dot, then j becomes 1, prints dot, j becomes 2, prints dot, j becomes 3, and the inner loop's done, and then system.out.println, and so on, and the result should be like this triangle of dots right here. The next exercise, so first, originally, I equals 0, j equals 0, k equals 0, prints 0, 0, 0, then k becomes 1, then prints 0, 0, 1, k becomes 2, 2 is not less than 2, so then I'm out of there, j becomes 1, and then k becomes 0, prints 0, 1, 0, k becomes 1, prints 0, 1, 1, k becomes 2, then that doesn't work, so then j becomes 2, that doesn't work, so then I becomes 1, j becomes 0, and k becomes 0, then prints 1, 0, 0, k becomes 1, prints 1, 0, 1, k becomes 2, doesn't work, then afterward, j becomes 1, k becomes 0, then prints 1, 1, 0, k becomes 1, prints 1, 1, 1, k becomes 2, doesn't work, j becomes 2, doesn't work, I becomes 2, doesn't work, then we're done. Basically the binary numbers from 0, 0, 0 to 1, 1, 1. Next exercise, print all ordered pairs of integers I, j from 0, 0 to 25, 25. So for this one, just this for loop from 0 up to 25. Then another for loop from 0 up to 25. Then I print the ordered pair. And then the output is this. And notice that the inner loop always runs through an entire cycle before the outer loop finishes once. So the inner variable always goes through an entire cycle before the outer variable changes at all. So the next exercise, print all ordered pairs of integers ij with 0 less than or equal to I less than or equal to j less than or equal to 25. So for this one, I starts from 0. It might be tempting to go up to j, but we don't have j defined yet, so we must go up to 25, I plus plus. Then now we start from j equals I, because now we do have I defined. Then we go up to 25. Then j plus plus. Then we print the ordered pair as usual. And then the output is normal. The next exercise, print all integer multiplication facts from 0 times 0 is 0 to 12 times 12 is 144. So for this one, I go from 0 to 12. Then j goes from 0 to 12. Then I print the multiplication fact, which is I times j equals I times j. And notice that the I times j is calculated first, so we won't have problems with the string concatenation. And that prints all those multiplication facts. The next exercise, print all ordered triples of integers I, j, k with 0 less than or equal to I less than j less than k less than or equal to 10. So for this one, I goes from 0 up to 10. Notice you can't go up to j because that j is not defined. Then now we can go from j equals I plus 1. Notice j is strictly greater than I. Then we can't go up to k because k is not defined. So we go up to 10. Then in the definition of k, we start from j plus 1 to ensure it's greater than j. Then k goes up to 10. Then k plus plus. Then I print the ordered triple, as shown. The next exercise, print the following but with 30 rows, basically this triangle of dots. So 30 rows, so starting from row 1 up to row 30. You could also start from 0 and go up to 29. Then for int j equals 0, j is less than I, j plus plus. Basically ensure that row I has I dots. Then just system.out.print a single dot. Then after a row, I do system.out.println, and then I get this dot configuration.